The three-body problem is a classic puzzle in physics and astronomy. It asks if you have three massive objects like a star, a planet, and a moon all pulling on each other through gravity, can you predict exactly how they'll move over time? With two bodies like the Earth and the Sun, the math is simple enough. Their paths follow predictable orbits like ellipses. But with three objects, the situation gets much more complex. The gravity from each one affects the others constantly, creating a system that's sensitive, changing, and difficult to predict. The motion becomes chaotic, meaning even tiny differences in starting conditions can cause totally different results. In a three body system, each object is pulling on the other two at all times, and their speeds and positions are constantly shifting. That makes the math messy and unstable. Even a small change, like a tiny push, can change the whole future of the system. But some are more stable than others. For example, the Sun Moon Earth system is a three body problem, but it's still fairly predictable. That's because the Sun is so massive compared to Earth and the Moon that it dominates the system's motion. And because the orbits have been stable for billions of years, we can model them very accurately. So while the system is still technically chaotic, we can predict things like eclipses and tides with great precision, at least in the short and medium term. For most three body setups, we need to use numerical simulations, which calculate the motion step by step using math and algorithms. We see three body systems across the universe. Triple star systems are common, and many show unstable or shifting orbits. Some exoplanets orbit stars in these systems and experience chaotic gravitational forces. Here in our solar system, missions like Artemis or the James Webb Space Telescope rely on precise gravity models. NASA uses Lagrange points, where gravity from Earth and the Sun balances out, to park telescopes in stable spots. These points come from special three body solutions. So while many three body systems are chaotic, careful modeling and simulation let us work with them in real life. This problem changed how scientists think about motion. It helped create chaos theory, the idea that some systems, even if they follow the rules, can still be wildly unpredictable. It's important for studying how planets form, move, or even get flung out of their solar systems. And it's had an impact beyond science, like in Liu Cixin's novel, The Three-Body Problem, where unpredictable gravity creates massive challenges for an alien civilization. In the end, this problem reminds us that the universe, while beautiful and ordered, is also full of complex surprises. Thanks for watching, and make sure to like and subscribe for more astronomy videos.